Hi, Assalamualaikum. My name is Ummi Raihanah binti Roslee and my matric number is DE210061. So I am from section 3, group 5. We will present electromagnetic shock absorber that relate to chapter 2, magnetostatics. So I will present the introduction. An electromagnetic shock absorber is a form of shock absorber used in vehicle to improve ride comfort and stability. It is sometimes referred to as an electromagnetic damper or active suspension system. It employs electromagnetic principle to regulate the suspension response to varying road conditions. Electromagnetic shock absorber, in contrast to typical passive shock absorbers, actively manage the damping force by electromagnetic principles rather than mechanical valve and hydraulic fluid. In consequence of the magnetic field intensity and damping force are adjusted by the control unit, which swiftly modifies the current flowing through the electromagnets after continuously analyzing sensor data. Next, problem statement. Traditional shock absorbers dissipate energy from vibration and shock using fluid dynamics or mechanical device. Nevertheless, an increasing demand for more modern and effective shock absorber system, an electromagnetic shock absorber can provide better responsiveness, precise control, and improved performance in damping vibration and shock by utilizing magnetostatic principles.
Assalamualaikum warahmatullahi wabarakatuh. Today I'm Waleed bin Sajjad, which is matric number is AE190026 from faculty FKE. Today I would like to present about our project, which is shock absorber. Okay, today I will present about the test is objective for our project. Okay, for the number 1, to create magnetostatic design that successfully control and dampens vibration and shock using magnetic fields. Secondly, to design a prototype that is compact and compatible with the standard shock absorber installation in automobile or mechanical system. Okay, for number 3, to optimize the power consumption of the prototype electromagnetic shock absorber. And lastly, for our objective is to ensure that the project adheres to safety requirements.
Hi and Assalamualaikum. My name is Siti Nursyakinah Maisarah binti Abdullah. My matric number is DE210103. So I will explain the methodology. So for the first is flowchart. So for the flowchart, we start the system and then we apply the force to the prototype, and the prototype will pass through the obstacle, which is the system check whether the spring of the parameter is tension or not. This threshold could be determined based on the desired performance of the shock absorber. If yes, the system proceeds to the next step, which is analyze head of the obstacle. The system will look back to the beginning to repeat the process and adjusting the shock absorber as necessary. And if no, which is if not getting any changes in parameter, the system will analyze the tension of spring and then proceed to the end and then end the system. So that is for the block diagram. For the block diagram of prototype system, first is the force was applied in the system and the prototype will moving when the force was applied on it. Next step is electromagnetic actuator, which is how the shock absorber react when passing through obstacle, whether the actuator extract or retract, and then it will pass through the spring suspension system, and then we get the output of the system.
My name is Nawwal Binti Radhi with the number matric DE210047. So today I will explain our related formula to the shock absorber. So let's start with the very first formula, which one of the principle in magnetostatic is Ampere's law, which establishes a connection between the magnetic field surrounding a closed loop and the electric current flowing through that loop. Ampere's law states that the integral of the magnetic field B along a closed loop is proportional to the permeability of the free space, multiplied by the total electric current passing through any surface enclosed by that loop. So our formula for the Ampere's law is phi B multiple with dl is equal to mu naught multiple with I. So the phi here is the denotes line integral around a closed loop. B is the magnetic field. dl is the infinitesimal length element along the loop equal to the mu naught, which is the permeability of free space. And lastly, I is the total current passing through any surface bounded by the loop. Moving to the next formula, which is the calculation of shock absorber, generally relies on its damping properties. A frequently employed equation to depict the damping force of a shock absorber is the velocity proportional damping formula, which can be stated as F is equal to C multiple with V. F here is the damping force exerted by the shock absorber. C is the damping coefficient or damping constant. And lastly, the V is the relative velocity between the suspension and the wheel. And the third formula, which is the last formula, represents the relationship between the force exerted by the shock absorber and the relative velocity of the wheel or a suspension. The damping coefficient C determines the resistance provided by the shock absorber and is a characteristic of the specific shock absorber being used. So this is the third formula, which is F is equal to C multiple with V2 minus V1. F here is the force exerted by the shock absorber, C is the damping coefficient, and V2 is velocity of the wheel or the suspension at the end of the stroke, and V1 is the velocity of the wheel or suspension at the beginning of the stroke. So I think that's it from me, from the related formula. Thank you.
Is the construction and design of electromagnetic shock absorber. This is the overview inside the absorber. So, this part will explain how the electromagnetic shock absorber works. When the vehicle hit a bump on the road, the spring and shock absorber gets compressed. While compression, the piston gets pushed, then they all will be moved through the piston channels. It dampens out the force and it tries to just stop moving. So, we send a current to the coil of copper wires inside the absorber. It will create the magnetic field. So the magnetic field is passing through the piston channels where the oil is going to passing through and activate the suspension. Due to magnetism applied, the iron particles in oil bond with each other. It's gonna line up all these tiny little magnetic particles inside of the suspension, and they are gonna make this oil increasing the viscosity. The oil is gonna have a much tougher time moving through the layers of electromagnetic particles, like just holding in place. So the oil gets restricted because of the magnetic force and prevents that piston from moving. Lastly, the suspension become a real steel system.
Hi, Assalamualaikum. My name is Ardiny Hamidah binti Muhammad Yusof. My metric number DE 210105. So I will continue to do the prototype analysis and discussion. So based on the data, it shows that the spring tension at the prototype depends on the height of the obstacle. When the vehicle passes through a thin obstacle, the spring tension is small. Then, medium height of obstacle applied to the vehicle result of spring tension is fair. Lastly, spring tension is big if the height of obstacle is high. So therefore, it can be concluded that if the height of the obstacle is high, then the spring tension is big. Generally, function of shock absorber to maintain the vehicle condition safe and smooth. The spring tension changing depends on the obstacle because shock absorber is compressed, and also it will rebound. The discussion with both compress and rebound mechanism will give resistance movement as shock absorber compress. Fluid inside the piston will dampen force to stop moving. In real life, it actually called as avoid vibration. Since the fluid called magneto-radiological fluid, then it has some little tiny metal particles, and then it will cause both of it magnetically attracted.
Okay, for the next part is conclusion. Electromagnetic shock absorbers have potential to greatly improve car suspension system by offering adaptive damping, energy harvesting capabilities, and interaction with other car or other vehicle control system. As technology advances and obstacles are overcome, electromagnetic shock absorbers may become a standard component in future vehicle applications, improving both comfort and performance. That's all from me. Thank you.